Problem 21. Let Px be the unique polynomial of minimal degree of the following properties. Px is leading coefficient 1. 1 is the root of Px minus 1. 2 is the root of Px minus 2. 3 is the root of P3x. And 4 is the root of 4Px. The root of Px are integers with one exception. The root that is not an integer can be written as n over n, where m and n are relative prime integers. What is m plus n? Okay, so we're told that so 1 is the root of Px minus 1, so P1 minus 1 equals to 0, so P1 is equals to 1. And then we also get 2 is the root of P2 minus 1, so P2 minus 2 minus 2, so P2 minus 2 equals to 0, so we get P0 is equals to 0. And then we're told that 3 is the root of P3x, so P3 times 3 is equals to 0, so P9 equals to 0. And if 4 is the root of 4Px, so 4P4 is equals to 0, so P4 equals to 0. Okay, so now we know that the three roots are 0, 4, 9 are three roots, right? So we want to write it in the A is going to be the leading coefficient, and then we have x minus 0, x minus 4, and x minus 9. Okay, and let's expand this, and expanding this we get ax squared minus 13ax ax cubed minus 13ax squared plus 36ax. Okay, so we know the leading coefficient must be 1, so we'll divide the whole equation by a to get x cubed minus 13x squared plus 36x. And then let's check if the coefficients sum to 1. So we have 1 minus 13 plus 36, but that's equals to 24, which is not 1, so this does not work. So the degree of the polynomial needs to be larger than 3. Okay, so how do we get a high degree polynomial? We multiply what we had already by another x minus k, so k for any. Yes, okay, let's expand this now. So expanding this we get ax to the fourth power minus 13 ax cubed plus 36 ax squared minus kax cubed plus 13 kax squared minus 36 kax. Okay, so now let's add the coefficients. Let's divide the equation by a again. So we have x to the fourth minus 13 x squared cubed plus 36 x squared minus kx cubed plus 13 kx squared minus 36 kx. Okay, now let's check the coefficients sum to 1. So we have 1 minus 13 plus 36, minus k plus 13k minus 36k. Okay, and this should be equals to 1. Okay, so we get okay, so and then we solve this. We solve for k, and we get k is equals to 23 over 24. Okay, now let's double check just to make sure that that k is going to be the root that is on it. That's going to be the root. So okay, let's double check. Okay, so we have x minus 0, x minus 4, x minus 9, and okay, we have x minus 0, x minus 4, x minus 9, and x minus 23 over 24, right? Okay, now let's plug in p of 1 equals to p. Let's plug in p of 1 minus 1. That gives us 1 times negative 3 times negative 8 times 1 over 24 equals to 1 minus 1 equals to 0. P of 2 gives us also gives us 0, and then all the ones that we said before, like these, they all give us 0. So then we know we know that the k must be 23 over 24. So if k is equals to 23 over 24, so then mn, because it's the root that's not an integer, so mn is equals to 23 over 24. 23 and 24 are relatively prime integers, so m plus n is 23 plus 24, which gives us 47. So the answer is choice D.